Welcome. In this video, I will go over how to find the equation to a plane tangent to a surface at a specified point. Namely, here's this function g, given by x squared minus y plus ln of x minus y. And then, of course, I forgot to write down the point, at least type it up, but I have it in my notes, the intended point. So we're going to do this at the point 2, 1, 3. So at this ordered triple here. Okay, so first recall that the equation for a plane tangent to a surface at a specified point is given by z equals the function, in this case g, evaluated at the x and y value of this point, so the z value here, which we're given in this case is 3, plus the partial derivative of our function of two variables, again evaluated at this point, times x minus the x value of this point, plus the partial derivative with respect to y, evaluated at the same point, times y minus y naught. So we were given this part here, g evaluated at 2, 1 is equal to 3. Okay, so next let's work on this here. That is the partial derivative of g with respect to x. We treat y as a variable, so the derivative of x squared with respect to x is the same. It's just 2x. The derivative of negative y with respect to x, since y is treated as a variable, is 0. So this will just vanish. The derivative of the natural log of x minus y, well, that is going to be 1. Oops, I forgot to plus right there. 1 over x minus y times, now the derivative of x is going to be 1. The derivative of negative y is 0, so that's just a 1 here, and I'll omit that. Well, there, 1. So this is 2x plus 1 over x minus y. So g of x evaluated at 2, 1, well, that's equal to 2 times 2 plus 1 over 2 minus 1. So this is 4 plus 1 equals 5. All right, so we're done with that portion. So now let's go ahead and find the partial derivative of g with respect to y. So g of y is equal to, well, the derivative of x squared with respect to y, since we're treating it as constant, will vanish. The derivative of negative y is just negative 1. And the derivative here is going to be, again, 1 over x minus y. And now x is treated as constant, so this is 0, minus the derivative of y, which will be 1. Well, the derivative of negative y is negative 1, I should say. So let me multiply by a negative 1. So this is a negative 1 minus 1. Well, actually, I don't like starting with a negative. So I'll write this as 1 over y minus x minus 1. Now g of y evaluated at 2, 1. And before I go on any further, you could have just left this as negative 1 minus 1 over x minus y. Rewriting it so everything leads with a positive is just a preference of mine. So I have 1 over 1 minus 2 minus 1. This is going to yield negative 2. Okay, so the tangent plane to G at 2, 1, 3 is given by z is equal to 3 plus 5 times x minus 2 plus negative 2 times y minus 1. And if you're not seeing where these came from, this is the 3 here. This is our partial derivative with respect to x evaluated at the point times x minus the x value. Similarly, this negative 2 comes from the partial with respect to y times y minus the y value here. So z is equal to 3 plus 5x minus 10 minus 2y plus 2. And this simplifies to z is equal to 5x minus 2y minus 5. Now, in a previous video, I showed you how to look at this using GeoGebra, a free online app or an app you can get for your phone that is a fantastic tool for any math student. I'm not going to go over how to do it in this video. So if you want to see how to do it, please watch my previous video where I show you how to verify your result. That is how to graph this, how to graph the point, how to graph your plane, and rotate everything around so you can verify that your plane is indeed tangent to this point visually. If you want to see how to do that, please look at the previous video. Anywho, hopefully you found some use in this. Either way, useful or not, please keep calm and math on.